Hello, Amin. Hello, Mike.
Hi, Amin.
Hey,
Hi,
Caio. Hey,
Caio.
Mike. Hey, guys. Thanks for having me on this session.
Awesome. Thank you for joining us.
Absolutely.
So, for how long have you been an iOS developer?
Well, I've been an iOS developer for almost 7 years now. So I'm currently a senior iOS developer, and I kind of mentor the juniors over there, but there's still so much to learn. So, yeah.
Awesome. 7 years. Congratulations.
Absolutely.
Thanks. Started with Objective-C, and it was such a switch to Swift, but I'm glad.
Yeah.
You're happy with Swift?
Yeah. In fact, I find Swift a very clean language, and things are just so much better. I don't know. I've taken a liking for Swift a lot more than Objective-C. So yeah.
Yeah, the same. I like both, but probably Swift is favorite now.
Yeah.
Awesome. How can we help you today?
So yeah, I have issues with I know how to do my view models, but there are things that I would like to get. I would like to see if the view model that the kind of view model that I create is the way to do it, or there are better ways. Also, I recently I had a challenge where we had to introduce some custom animations, and the behaviors were very specific, and they follow a very set sequence. So I did face challenges there, but I want to know whether there could have been a better way to do this. And can I unit test? Do we unit test animations or not? And uh, also, if we unit test animations, how do we? I don't write unit tests for my view controllers, but I do write unit tests for my view models. So I would like a little demo, or I would like a little help in what's the best way to write a unit test for a view controller.
Okay, awesome.
Yeah, it's good. One by one here.
Yeah, let's go one by one.
Yeah.
Many questions.
Yeah.
Okay, so first of all, you sent us a project, so let's have a look at the project.
Mhm.
Can you talk a little bit about this project here?
Yeah. Well, this the requirement is basically we have a leaderboard. So anytime we come to the leaderboard screen, we will show we'll have maximum 50 players, but that doesn't matter. But every time the leaderboard updates, we will be getting the player will be moving up, and whenever the player moves up, there's going to be a specific animation. So we have two types of animations. One is on top, which is in the top three, and the other animation is in the list, which happens only in the list. So these two animations are in different view controllers, but they are very that's the requirement, very specific requirement. So
Okay.
I've made it to loop, so you can refresh a third time and a fourth time, and it'll come back to the first. I cycle through the responses through in my provider.
Okay, we're just mocking some responses here for demo purposes.
Yes. Yeah. I've written some basic unit tests for the view model. Yeah. And also over
Okay.
here, we have the scenario where there are either three players, we only show a list, or if there are four players, we show a list and the top three. So these kind of business logic is also involved.
Okay, so if there's 3 or less players, you just show a normal list like this.
Yeah.
But if there is 4 or more, then the top 3 ones have a bigger like avatar
Yeah.
screen here,
Yes.
and the rest goes in a list. So in this case, we
Right.
have 4, and if you have more than
Mhm.
4, like here,
Yeah.
they go at the top.
And also, yeah.
Yeah, you were saying, Amin, and also?
Yeah, and also as you scroll up or down, the top three kind of animates in a parallax behavior.
Yes. And they snap, right? The table view snaps.
Yes, it
the
snaps
top.
either to the top or to the bottom. So this was, as you can see, very specific by the designer, and yeah, needs to be done.
Yes. Okay.
Yeah, neat.
So everything's
Awesome.
custom, right? The animations. It's not using any of the pre-built animations you get from
Yeah.
UIKit.
Yeah, I couldn't see how to use them because the animations are very specific. Like if you animate once, you will notice the way the cells reload, they have to be one after the other. So they kind of pop down, and that behavior is just not default.
Yeah, it's custom animation here. Looks good.
Yeah.
Okay, and
Fine.
also when you refresh, it scrolls the table view to show the current player, right?
Yes. Yeah.
Whatever the current player, which is the owner, right, of the device here, the user,
Right.
it scrolls to his ranking.
Yeah. The logged in player. So
Right. It's always either the top, the bottom, or in the middle.
yep.
Okay. Cool. All right.
And
So
also you would have noticed the points they animate and the rank goes down. So those are also the tiny animations which are required, like a
and if I
counter. So you'll
select
find a timer.
one,
Yeah.
if I select a
Over here, I've
player
just
here,
dummied it. If you select a player, it'll either show an error or a success. I just put it on a bool random. So
oh,
uh,
randomly,
yeah, just to
just for
test
demo.
my success and happy pathways, like success pathways.
It's failing every time. What are the odds?
Yeah, I think yeah, exactly. It's
All
pseudo
right.
random.
There you go.
Yeah,
Okay, awesome. So there is some error handling here in all the screens. Nice.
yeah,
All right. So let's go one question at a time. First, view models. Do
yeah,
you have questions about the view models in this approach?
yeah. So starting with the view model, firstly, as we are going through this, I would like a general review on what is good, what is bad, what could have been done in a different way. So one takeaway over here is that the view model that I have created is very specific to my view controller. So you will notice I have two arrays, one top three players and one list players. So this will always work with a view controller which can divide the screen into the top three and the bottom list. So um, like this is one of the things. The second thing is that whenever I load the view model, it only tells the view controller to refresh, and the view controller at that point will check the state of the view model and will do some logic. So over there, there's actual UI logic which I have not tested. So if somebody doesn't do it in the right way, it could kind of cause an issue.
Right.
Okay, so let's see here. We have a view model that controls here the state for this view, right? It manages,
Yeah.
it talks to a leaderboard provider that probably will make a network request, get
Mhm.
the leaderboard, and then it will transform it into leaderboard player view models.
Yeah.
And you are controlling here the state of you either have three at the top or you have just a simple list
Yeah.
with these
Well,
two
actually,
arrays. Right?
the view controller decides that. It'll check, so my view model is like the source of truth. So the view controller will check, okay, I have top three, so I should show the top three. It's like that.
So it checks if this is not empty. If the
Yeah.
top three is not empty, then it shows this special UI here at the top.
Yeah.
Okay. And then the list players. But what happens here if by mistake you put like 4 view models in this array here?
Yeah. So that's another question for the view model. My view model, as I told you, is very specific to the view controller. So I have set up my view model to always load only 3 in that array. So, and I have written the unit test. So if anyone does make a change over there, my unit test will fail. So I've kind of protected myself over there.
Okay.
Awesome.
So this is protected by unit tests, not by the
Yeah.
type system. Yeah, that's fine. That's absolutely fine. Okay. So you have a test that every time if you have 3, this will be empty, and you have all the 3 in the list players.
Yeah.
If you have 4, there'll be 3 here and 1 in the list players, and so
Yes,
on.
exactly.
If you have
Yeah.
two, both will be here. Okay, so it controls the state of the UI in the view model, if it's going to show things at the top or not.
Yeah.
Usually, I wouldn't do it like this. I would keep only one array, and the UI would decide how to display that in the UI instead of putting this
Okay.
logic in the view model. But it depends. It also works this way. But then, as you said, this view model will be very specific to that specific
Yeah.
UI,
Yeah.
right? So it's very coupled with that specific UI, the way it's designed. And it's fine. If you want to couple the view model with the UI, you just won't be able to use it in different contexts. But
Okay.
if that's what you want, that's fine as well. Otherwise, you have one list of players, for example,
Mhm.
and in the UI, you decide how to display it. For example, you can have a collection view layout that will check if there's more than 3. You will have a special layout for the first 3, and the rest will be normal.
Okay.
And then the view model only controls the state, the data.
Mhm.
And the UI decides how to render that state. Make sense?
Yeah, it does make
And then
sense.
you have a
So, yeah, sorry. So that does make sense. So that means I would have to decide a different kind of UI element to use, like UI collection view. But at the same time, all that logic would come into the view controller. So then now my view controller has some kind of, would I say, business logic in that way? Like um, it would have business logic in the view controller as well. So yeah.
yeah, that's pretty much a UI logic, right?
Yeah.
How to display something. Because you could use the same view model here to display the top 3 at the top here, and then you can have on the iPad, the designer can say, well, I want the top 5. We will create a new view model. If you have this kind of requirements where you want to have the same view model and adapt to different screen sizes, if you like change the orientation to landscape, I want to show the top 5 rather than top 3 because there's more space now.
Right.
Now, the view model needs to know about orientation. Then the view model starts getting too complex because it needs to know about UI implementation details about orientation. It needs to know about screen size. And at some point, you're going to have to pass the CG rect to the view model. And then your view model will start becoming more view than the model.
Right.
Yeah, exactly.
Right,
that
so
that was
it
the
really
challenge that
depends.
I was facing. Yeah.
So it really depends on what you're trying to achieve. But usually, I would keep one array and decide how to render that array in the UI, because rendering is more UI, is more view logic than view model logic. And I will keep the view model logic just more focused on managing the state of the view. Now, how that is rendered, if it's animated, if it's using constraints, if it's using auto layout, if it's going to be pinned at the top or the bottom, that's a decision that I will do in the UI because that's about how it looks, not how it behaves, right? And I try
Yeah.
to separate the behavior from the appearance. Appearance is more about view logic. Appearance is view logic. Make
All right.
sense?
Yeah, it makes a lot of sense. So, yeah, so that means I just move the whole creation of the arrays into the view controller, the 2 different arrays, which I would be feeding to either the table view or to the top container view that I have, the top 3.
Yeah, that's some implementation details. You may not need 3 arrays because if you have a collection view layout, for example, this is all decided in the collection view layout without different arrays. You have one array
And you have
and
the
you have
logic in there.
a list of cells, a collection view, a collection of cells, but the layout for each cell is different. And
Yeah.
Okay.
this is one section, but you just lay out it differently. It's just that here you are using a table view, and a table view is just a static list of cells vertical. But with collection views, you can have like side-by-side cells horizontally, vertically, and you can mix and match everything.
Right. Okay.
Right. So, and then you can have one list view controller in the view model, and just the layout changes for the cell. If it's the top 3 cells, they will have a different layout, and that's it. Just the layout changes, but it's still part of the same section. It's still one list of things.
Okay.
And then you move away this view specific logic from the view model if you think it's going to be beneficial to you.
Mm-hmm. Yeah.
Does it answer this first question about these 2 different
Yeah,
arrays?
definitely. Because the main point is, yeah, what if I was designing this for an iPad, or if I change the orientation, then definitely just showing 3, let's fit in more. So yeah, definitely that should be a UI specific area to write our code in. All right, cool. I'll keep that in mind.
Yes, awesome. And then you mentioned about the callback when there are changes to the view model state, right? So
Yeah.
how it works right now, the view controller calls load on the view model, right? It sends this message to the view model, say load, and there's a completion block, but you don't pass any result back, right?
Yeah, correct.
Which means the view controller needs to listen to this completion callback and then investigate the view model and say, just check all the properties and see if anything changed, you need to update the UI,
Yeah, exactly.
correct?
So it could
So
get a
let's have
bit
a look at
messy because what if I'm changing too many objects? I'm not using binding, I'm not using combine. So it just checks the entire state of my view model. So
Yeah.
okay, here. We call load on the view model,
mhm.
and as soon as we get a callback, we don't get a result. We don't know if it failed, if it succeeded. We don't know what changed. We just know that the view model may have changed.
Yeah,
So the view controller needs to check all the properties of the view model.
yeah,
Okay. So as soon as there is a callback, the view model finished loading. The view controller will call refresh UI on itself and check what changed. Let's say here,
yeah.
it checks if the view model has top 3 players, is not empty. Well, if it is empty, we hide the top 3 players.
Mhm.
Otherwise, we show the top 3 players. And what is the table view container? Hidden.
Uh, the the table view container is the one on the top. Um, yeah, it'll
Okay, let's
just
have a look at the
hide that. Yeah.
layout. So we have a container here.
Yep. So inside this, I embed that other view controller.
So this is the table view container,
Yeah.
correct?
Yep.
And this is the table view.
Yeah.
Okay, table view is inside the view container. All right. So the header here is not part of the table view.
Yeah. It's not.
Okay. So when you scroll the table view, you're listening to scroll events and updating
Yeah.
the constraint for the top header view. Okay. All right. So do we have any downsides? Do you have any issues with this approach where you complete with no result and you let the view controller check all the properties? Have you had any issues before with that?
Well, so far, the way I've designed my view models, I don't really face any issues with this kind of behavior. Like I just check the whole state, and my view controllers are not very complicated. So I haven't come across a case where the view controller has got too complicated. I always compose my views in different ways. So um, I've not run into a problem so far.
Okay. But you're curious then if there's a downside.
Yeah,
Is that it?
yeah, yeah.
Okay. I think one downside is that you have to move a lot of the logic to the view controller. And since you're not testing the view controller, if there's some bug in there, it'll be hard to catch.
Yeah.
Yeah.
Yeah. Plus, it might not be too explicit. Like for example, you start there, you stop animations or you end refreshing, and this might not be very, intuitive as like why it's happening in the first place.
Yeah.
No, like this is set to hidden. It's not rather.
There's a lot of logic here. Like if the view model is not empty below the table view, else if there is a message,
Yeah.
this will be an error message, for example,
Yeah.
right?
Correct.
And then you show the error message. So the error logic is hidden here. It's not very explicit because the error logic is if the list is empty and there is an error message, it means there is an error.
Yeah.
But it's not very clear. Looking at this code, that's what it means, you know? And what if there is an error, but there are still players in the array? So the view controller needs to know about implementation details of the view model, knowing that if there is something in this array, it means that there is not being an error. But this is more like implicit logic about implementation detail of the view model that the view controller ideally shouldn't know about, right? If there's an error, the view model ideally should tell the view controller that there's been an error directly.
Yeah.
Makes sense? Then the logic will be much more explicit.
Right. So one question regarding this is, so yeah, I know it's a bit confusing. So that's what I would like to improve on that. But also, there could be cases where the error message could either be a simple error message to show on a label, or it could be an error message which I need to show in a pop-up or in an alert. So if that case comes in the future, again, I would have to do something in the view controller. I mean, of course, we would have to do, but yeah, the business logic keeps increasing here.
Yeah, you would
So
have
how
to
would
check like if the message is a specific message, you will show it in a alert controller, or you would put it on the header here on the top or in the middle of the screen, and so on.
Right.
Yes, and then this logic will start growing in the view controller, and since you don't have tests for the view controller, there's a lot of risk that there will be a bug in there. Right?
Yeah, that's what I'm scared about.
Yeah. So if you move this logic to the view model, it's easier to test this logic. And you still need to write some unit tests through the view controller to make sure that when there's an update in the view model state, the view controller is reacting accordingly and updating the table view or is showing an error message. And this should be simple tests like, oh, change the view model state, call a method in the view controller, the callback method, and assert that the view controller has an error message or it has 3 cells and the cells are in the right place, for example, with the right data. You don't need to test the frames. You don't need to test that something was animated, but you need to test that the data in the UI is correct. It shows, it reflects the state of the view model in the UI. And those should be very simple, very fast tests. You don't even need to run UI tests. It can be, actually, you instantiate a view controller, you set the view model state to a specific state, and you check if the view model is rendering itself, right? The view is rendering itself according to that state in the view model. Those should be very fast, very easy to create tests as well, and gives you more confidence. But all this logic ideally should be moved to the view model. For example, let's have a look at here. Let's say you have an error message state. This state may change. Right? In MVVM, one of the patterns that are very common with MVVM is to have observable state. As you mentioned, you could use Combine or XSwift, but you don't want to use these frameworks. Absolutely fine. What you could do instead is just use a closure. For example, if you have a state of a message text, you can have a, let's say, message changed callback. It can be simply string to void. Well, it's an optional string, right? Because you may have a message or not. So we can say something like this. Message changed.
Right. Yeah.
Right? A callback in here. So let's make this optional for now. So we don't need this add constructor in an initialization time.
Yeah.
Okay. Right. So now the view model can decide when to tell a message or not, instead of just changing its state.
Yeah.
It can notify any listeners, anyone that's set up as a listener, about this change. For example, we can say like did set here. You call this message changed with the new value message text. Every time the message text changed, you will notify any listener that is listening to this.
Right.
Right. So in the view controller, probably like as soon as you create the view controller, you have like setup bindings, for example. Bindings. A private function setup bindings. And here you can get your view model dot message changed, and now you get a new message. do something like if new message, or you just update the UI. What is it? Message label.
Yeah. I
Text
just
equals new message.
yeah. Right.
Make sense?
Yep. Yeah. Actually, this is really neat.
Now you set this
Good.
binding once when you create the view controller, when the view is loaded, and that's it. If there's any change to the state, the UI will be automatically updated,
Right.
right? And the view controller doesn't need to know when it changes. It just needs to know that if it changes, I will update the UI. They are, that's it. They may change for many reasons. Many reasons might show a message here. Now the view controller is decoupled of the reasons why a message might be shown, and
Right.
how and when. It just know that if this message was changed, the UI will be updated immediately.
Hmm.
And you write a unit test for that as well. Every time the view model sends a message changed event, the UI is updated.
Right.
And you can provide all this kind of observable state for all the properties here. You could have a list players changed event, top 3 players changed event. Error message, for example, if we have a specific error message, you mentioned you can have more than one error message. You have an error state changed, and you pass like a string as well. Now, since you have 2 different kinds of message, here's just a general message that maybe is not an error, and you show this in a pop-up, or the error state you show in a pop-up. Now the UI can decide, like, these are 2 different streams. If I receive a message from this stream, I'm going to show an alert controller. If I receive from this stream here, I will show it, I don't know, in the
drop down, something like that.
Yeah, on the header or the table view, something like that.
Right.
Or in the bottom here, and so on. Another way about errors is use an enum to say types of errors in here. It was either a critical error that requires user attention, or it was like just a, I don't know, warning. Depending on the severity of the error, if it needs user attention or not, you decide if you will actually lock their screen with an alert controller, or if because they need to decide either retry or cancel, for example, or it's just a general message saying, hey, something went wrong here. So you can create an enum with types of errors, right? Like error conforms to Swift error. Then you can have different types of error, and you can have a stream that sends errors. Then the view controller will decide, depending on the error, if it can be retried. I will show an alert controller with a retry button, and so on. This requires attention, or you can even pass a retry closure here. The UI doesn't even need to know how to retry. It just needs to pass the retry forward to the alert controller.
Yeah.
This is how you can deal with error. But the idea is that all this logic of changing the state should be in the view model, and the view controller should be as simple as possible. Just listen to those changes, right? That's the key in a MVVM approach, is that as you can see, the view model doesn't reference the view directly. It doesn't know about the view. It just manages the state. If there's a state change, you will notify any listeners. Now, those listeners may not even be a view. Maybe it's a logger. Maybe it's something else. Maybe it's like a unit test, right? Because in MVVM, you don't want the view model depending on the view. The opposite. The view model does not depend on the view. The view depends on the view model. It listens to it. The view model doesn't depend on the view. It just propagates state changes through any kind of observation pattern you are using. RX Swift, combine, closures, and so on.
Right. Yeah, I think this is a good. Sorry, Mike, you were saying?
Yeah, and I want to say that you don't have to have like an enum per se. Like maybe you have two types of errors, 3 types of errors. You could have different closures as well. It's like it doesn't have to be one type there. You can just expose
Hmm.
another closure, right?
Yes.
It's like a
So
network error state change.
yeah, so now the UI doesn't have to switch, by the way, right? It just implements the new behavior, listens for the new behavior and implements.
Hmm.
You have a network error and user error state change, and so on. And depending on what changed, maybe the UI will do
Yeah.
something else.
Right. Right. Yeah. So I was saying that I was not able to use combine because the project I'm working on still supports iOS 9. So, but this is definitely it's still the same. We are still observing it in some way. We have a closure. So yeah, I think it's thanks. Good idea. Thanks for this.
They're all callbacks at the end of the day, right?
Yeah.
Yes. Yeah, if you cannot use combine, that's fine as well. You can use simple closures. And sometimes you don't even want to use combine. It's good to have an alternative, a lighter weight alternative.
Absolutely.
Yeah.
All right. Okay,
Right.
so we answered this question about the
Yeah.
state. And in this way here, you don't even need a completion block here, right?
Yeah.
The view controller will just call load, and if there's any change to the state, and any time an error, a change in the state, it will automatically update the UI because the bindings were set once in the view did load, and that's it. So you can bind like there's a scroll here, the refresh control can immediately call load and not wait for a callback. You don't need to wait for callbacks anymore directly in the method invocation because you're already listening to state changes. It's much simpler to understand what's going on in the user interface side. The view controller will be so much simpler, easier to understand and manage.
Right.
Make sense?
Yeah, makes a lot of sense. So yeah, definitely. The code also stays uh, closer to where it needs to be performed. So yeah, it's a lot more understandable. Great.
That's it.
Yeah. So that's the MVVM mostly my concerns were mentioned. So I do have issues with animations. So
Mhm.
the animations that we have now, so most of the logic is again in the view controller. So you will notice after the load, I am loading the table view. I'm loading the top three, the header. So they have animations and they have to happen in a specific sequence. They are very hard coded. So what is the best coding path when it comes to writing custom animations?
Let's see. So reload table view. We'll perform some animations here. You need to figure out who is the current player and scroll to that player. Here you get the animation for free with UI kit, but you don't want to animate here, right? Okay. But here you get for free. If you're scrolling the scroll viewer, the table view here to a specific index path, you already get the nice smooth animation if you want.
Right.
Now you are mentioning the animations, the custom animations you were doing with the cells, right? When they show one by one, like this drop down animation.
Yeah. So
Yeah, I'm concerned
basically,
about creating animations with timers because you may have race conditions. If the user reload quickly the screen, you may have like inconsistent animations. You might jump around because the timers are still going on while the new update came at the same time, and they will conflict, right? So ideally, if you have timers and you do animations with timers, you need to hold a reference to the timer somewhere, maybe in the view controller. And before starting a new timer, you need to invalidate the old one. Timer dot invalidate.
yeah.
Otherwise, the animations might conflict with each other.
Right.
Ideally, it's better to use the animations that UIKit already provides because you get all this sorted out for you. But I know that some designers will want some very custom animations. In this case, you need to create custom animations. And table views themselves are not very friendly about these custom animations. So as I see here, you are iterating through a bunch of visible cells. Is that it?
Yeah.
Yeah, you get all the visible cells. You animate one at a time with a 0.15 second interval. So you get the current cell. You need to do a bunch of dispatching here to the main queue. Otherwise, it will crash. So you get the cell for that index path, and you call animate in the cell. So the cell knows how to animate itself. Let's have a look.
Yeah.
Okay,
So just like dropping down.
Okay, just performing some transformations, and then it goes back to its original size, right? Because otherwise you have issues with scrolling. Yeah, you should. If you're animating a cell, we should always go back to its original size after the animation, so you don't have any issues. Okay. Yeah, this is one thing about animations. They need to be sequential, right? There is temporal coupling. Like this needs to happen first, and then something else needs to happen. And there are UI kit animations like that you can do like frame by frame animations. It already deals with all this complexity of managing like timing. How is it called, Mike? Do you remember the keyframe?
Keyframe.
For example, here you have an animation that will take 0.1 second to finish, and another one 0.05. And you add a delay in this one because you want this to start when this finishes, right?
Yeah.
They need to be sequential. There are other ways you can animate sequential animations, and you set them up in one go rather than setting delays to make sure they happen sequentially. Otherwise, you might still have conflicts that are glitches with the animation. I forgot the API. Let's see. Animate keyframes. There you go.
Okay.
Have a look at this method. Documentation is pretty good.
Yeah, I will.
And then you can set up the whole animation there. In keyframes. Rather than setting delays to expect the other one. Or you can use completion. When an animation completes, then you call the other one. These start getting very complex. You start getting like nested callbacks, and it's hard to manage. But if you set up keyframes, like let's say you say, I have an animation of 1 second. For the first 10 seconds, I want these properties to change. After the first 10 seconds, I want this to change. In the next 10 seconds, and so on. And you set it up all in one go, and you run the animation rather than adding delays. It will be much simpler.
Okay.
To set it up. So check it out.
Yes, I shall.
And always invalidate the timer before running it again to make sure you stopped the previous executions. And the other problem is that since you are running these async calls here, you cannot stop this change, right? So you still may have glitches. Ideally, you shouldn't be dispatching to the main queue all the time.
Okay.
Because you can have glitches as well. You need a way of being able to cancel this. So you don't have conflicting animations happening at the same time. They might even lead to crashes depending on what's going on.
Right.
Now, animations, they are view logic. And view logic is in the view. I wouldn't put animation logic in the view model. I think that was one of your questions.
Yeah.
Now, do you need to test the animation logic? No, you need to test that. For example, if you want to set a label text, you're updating a label. And you want to animate that change. You don't need to test the animation. Like, there's no way to test the animation easily with unit tests. You want to check that the label text was changed.
Yeah.
It was updated. There's a new label text,
Right.
but not
So
that it was animated.
Exactly.
Okay.
It's the behavior, right? Setting the new text. That's what you want to check in your test.
Right.
Yeah, you're not going to write a unit test about the animation. Unless you're creating an animation framework and you want to make sure that the frames calculation are correct. Makes sense? But you should trust the UI kit will animate as you want. What you need to test that your code is actually setting the right properties at the right time.
Okay.
Right? You can test that like a switch is on or is off. That's a Boolean. You test that the state of the switch, not that the switch moved on and off animated. Makes
Okay.
sense?
Exactly.
Now, if you want to actually test how it looks after an animation, before an animation, in the middle of an animation, you can use snapshot tests when you're actually testing how things look. With unit tests, it's not about how it looks, it's how it behaves. You want to know about the behavior, about the state changes, are they correct, and so on. Now, if you want to test the actual appearance of things and make sure that there's no regressions with the appearance, because maybe you have some complex animations, then you can use snapshot tests. And you can take snapshots of each second or each frame of a second of an animation and make sure that it is moved, for example, if that's important. But usually you don't need to test animations because you have basic animations like fade in, fade out. Those things they're not very interesting animations. If you have a very complex animation, you want to make sure it looks good and there are no regressions, then you can write some snapshot tests.
Okay.
And the snapshot test is actually going to take a snapshot of the UI and you have a PNG that you can look at. And you save this PNG in Git. And next time you run the test, you will check that the new PNG matches the old stored PNG. If they are the same, fantastic, no regressions. If they're different, you need to have a loop.
Okay.
The test will fail.
Yeah, that sounds a bit complicated.
It's much slower, and it's much slower
Time-consuming.
than unit
Yes.
tests. It needs a lot of CPU cycles to render the views, then take a snapshot, convert it to PNG, save to the file system, load to the file system, compare like a bitmap. That takes
Plus,
time.
a lot of the new versions of iOS, like they have these extremely, like small changes that they might break your UI as well, so because this is like a pixel to pixel comparison that you're doing, right? PNG, so.
And if you're running a different simulator that has a different rendering algorithm that is smoother, it has a higher resolution, this snapshots will not match. So you need to always use the same simulator with the same setup. It's much more complex than unit tests. That's why you usually don't want to have many snapshot tests and test animations or test frame positions and so on. You test the logic. And if you have any critical area of your user interface that you want to make sure that no regressions on how it looks, then you can take some snapshot tests. But it shouldn't be your primary strategy. Primary strategy is unit tests because you run a unit test in 0.001 seconds. A snapshot test may take 0.1. And if you have 100 unit tests, it's going to take more and more time.
Yeah.
Make sense?
Yeah.
So
it does.
How things look like, how they are rendered on screen, and animations, view logic. I usually keep them in the view side, not in the view model. And we test the behavior, the state changes, not the animations. Only if it's very interesting, the specific animation, or you are creating an animation framework, then you can test that.
Yeah, depends on the
I hope
purpose. Right?
Apple is, I hope Apple is testing their animations because we rely on it every day.
Yeah.
All right. Any other questions about MVVM animations?
No, nothing about MVVM animations. I think that was it.
And
I do
about
have
unit tests?
I do have a few questions on unit testing. So I've already written a few tests for my view model. And generally what I do is I only unit test my view model. I don't write any tests for my view controller. So what are the do's and don'ts over there? And like, for example, now in this list screen that we were talking about with the animations and everything, if we did write unit tests for this screen, then would it be affected by these animations that are happening? Or do we avoid these scenarios and just test behavior?
Okay.
So
yeah.
first of all, view controllers and view models, they should both be tested. I mean, if you have no logic in the view controller, you don't need to test it. If you have logic in the view controller, ideally you need to test it to make sure nothing breaks and it does what it's supposed to do. Now let's have a look. There's a lot of logic in the view controller. What is the view controller?
Yeah.
You don't test things like, you don't want to couple your unit tests with implementation details. So I'm not going to test that the table view was registered with a specific nib. You don't need to test the estimated row height is 64. You don't need to test those things because those are how things look like. It's not interesting for a unit test perspective that the row height is 64, for example. It doesn't matter. It's about the behavior. So in a unit test, you will test the logic. For example, when the view model completes loading, the loading indicator should not be animated, should not be animating. Now, this is something interesting you want in a unit test to check that when it finishes loading, we are stopping the spinner, the loading spinner. And this is easy to test. You just check a Boolean, which is animating. Very simple. Assert is animating false.
Yeah.
That's an important test. You don't want to show that spinner forever. How many apps have this bug? Right? One unit test, you're never going to have this bug. Now,
Yeah.
the same for refresh control. It's not refreshing. One assertion. When I start loading, it is refreshing. It's refreshing is true. When I finish loading, it's false. Boom, very simple unit test. Behavior tested. We don't check constants and constraints in unit tests as well. But you can test that like some view is hidden now, because that's an interesting behavior. Like the UI state changed. It is hidden now. You don't need to test animations. What else? The state of the table view can be tested. Like how many cells are in the table view? Which data each cell is showing right now? Those may be interesting in unit tests. They are easy to write as well and give you more confidence.
Yeah, exactly. So you check also the integration there with both view model and view controller.
But if you have an onboarding screen, the first time you open the app, it shows a button, next, and a label with some text. Maybe you don't need to test that because there's no behavior in there. It's just static content, right? But when you have behavior, like when I reload these, some state changes, and when the view model changes, the cells need to be redrawn, and something needs to be shown. If there's an error, the label should show on the screen. All of this can be tested with unit tests in isolation. Like every if statement is at least two tests. When it's true, when it's false.
Yeah, exactly.
When this is empty and when it's not empty. Every time you have an if statement, you have at least two tests to cover that behavior. So it all can be tested. So you're already testing the view model, right? So you're already covering part of that behavior, but there is still a lot of logic here. Now, if you move all this logic to the view model, it will be much simpler to test the view controller because most of those if statements will disappear from here.
Yeah.
You have much less tests to write in the view controller. So ideally, you move a lot of this logic to the view model. How? Let's say the view model is loading something and it got a list of players that is empty. It should notify the view controller that the new state is empty. Like you can have a closure, like we just shown, like some kind of notification mechanism, like a closure or a combine publisher. Now, the view controller is binding the view with that state change and will either show or hide based on that state change. So the view model will decide when the header should show or not, for example. And the view controller will just listen to that state change and update the UI. So you can have here in the view model, for example, a loading state changed. And you have, for example, a Boolean, right? You're either loading or not loading. Now the view model will just listen to this and either tell the refresh control to start refreshing or end refreshing, just to update the UI and keep it in sync with the state of the view model. Now, the view controller doesn't need to do this logic everywhere. It's just a binding. If there's a state change here, if you start loading or finish loading for any reason, either because of a user interaction, either because it was scheduled to start refreshing every 5 minutes to always keep the UI up to date, the view controller doesn't need to care about why it started changing the state, why the state changed, but it can only react. Somehow the state changed. I don't care why. I'm just going to update the UI, the view state.
Yeah. In a centralized place as well. You don't have to, have this logic scattered throughout the view controller.
Yeah, otherwise you have this in multiple places. You need to start loading here, and you start loading there. You need to stop loading in another method. It's hard to keep track of this state. And more easy to introduce bugs as well. But if you keep it centralized, every time the state changes, this is the only place where the states can change. It's very easy to see where it changes and how it changes.
Yeah. Right. Another useful thing that you can do with a unit test there is check the state over time, right? So, for example, your view model starts loading. What should be the state of the view, right? Now, the view model stops loading. Again, what should be the state of the view, right? So it's like over time, you can check the events and the state. It's very useful as well because it reads like a story, right? Basically.
I also recommend you watch this session here that we released recently. Testing and refactoring existing. Can you see my screen?
Yeah.
Testing and refactoring existing iOS Swift code, where we show how to unit test a view controller.
Okay.
Write it down, and you will see exactly how to do it, from the first test until the last one.
Right.
With MVVM. All right. Does it answer your question about unit tests? I mean, the implementation, you will find it here, but in a more general, high level.
Okay, sure. So I had one more question. Yeah, that did question, and I will surely check out that episode 42. So yeah. So for my final question regarding unit tests. So right now I have not. I've just used a provider. I've used a dummy provider. I'm not getting the data from an API or from anywhere else. But in the future, when I will implement a provider which fetches the data from a URL, from some URL, then should I write a unit test for that API provider? And if I do write a unit test, do I need to use a mocking framework, or should I just trust that my view model is with whichever provider I give it, it will work? So yeah.
So the question for any kind of component, code is code, regardless if it's networking, if it's view model, it's controller, it's view. If there's logic, behavior, you want to test that. Make sure that there's a unit test in there. So in this case, you have some kind of provider interface. And at the moment, you have only a dummy provider implementing that interface for demo purposes, right? Now, at some point, you're going to have a real provider, like a network provider that will make a request. And this request will probably go through URL session. Correct? Let me move it over here. So network provider will implement the provider protocol, and we'll use URL session to make a request. You don't need to test URL session because Apple tested URL session, right? But your network provider will get back some data from URL session or an error, right? And there will be some behavior in there. What you will do with that data? You will convert it into some models, right? You can test this conversion. Make sure that if you are given a right JSON data, it will be converted to the expected models. So we avoid like mapping, decoding mistakes. Because there might be decoding mistakes in there. Maybe you're using the wrong date decoder.
Yeah.
Right. And you will not create the right date. Maybe you're using the wrong time zone and things like that. Maybe you can make sure that this conversion from data to rich models, Swift models, is covered. But you don't need to test URL session. You need to actually make a network request, and you don't need a mocking framework for that. Because you can either use URL protocol to intercept requests. Have a look, URL protocol. It's a very old class. Objective-C. But it still works. Every request the URL session makes, it goes through this URL loading system. So the URL protocol here, you have HTTP protocols, you have HTTPS, FTP, and so on. So you can create a URL protocol and intercept the requests and return whatever data you want. This is one way you can test without any framework. Just intercept any requests.
Okay.
Another thing you can do is to create a tiny HTTP client protocol here with one method, for example, to hide the URL session from your network provider. Now, when you're testing your network provider, you can use a dummy HTTP client or stub that returns predefined responses. And you create maybe an extension on URL session that implements this HTTP client. You don't need to test that extension if it doesn't do anything.
Okay.
Right? And then you can test your network provider. So should you test it? Yes, if it has behavior, you test the behavior. If it doesn't have behavior, you don't test the behavior. So this, for everyone that is watching this video, this works for any class.
Yeah.
Like
Exactly.
a network provider is not different than a view model or a view controller in this sense of if it has behavior, you want to test it.
And you don't have to have like a mocking framework, right? There's just techniques that you can use. And these mocking frameworks, they leverage the same techniques pretty much. So
yeah, if you're happy to
provide helpers,
couple your code with these mocking frameworks,
absolutely, yeah.
It's just one more dependency in your project, and you may have issues updating to a new Swift version. It will be one more thing to maintain in your CocoaPods or SPM.
Right.
So if you want to avoid it, you don't need it. You don't need these mocking frameworks. If you think it's going to be helpful and you're willing to pay the price if you have issues in the future, that's fine as well. You can use the mocking frameworks, but they're not mandatory. They can be helpful as well.
Right.
Makes sense?
Okay. Yeah, totally.
So you can test the view model in isolation. You can test the view in isolation, then you can test the view model, and you can test the network all in isolation on its own tests. And then you compose all of them together and run the application. Make sense?
Yeah, it does.
Awesome.
So generally, in this unit test, if the network provider had some behavior, then I would test it. But ideally, in such cases, all it does is it just gets a JSON, converts it to a codable model, and sends it forward to the view model. So generally, that pathway I've already tested in my view model test. So would I still do I still need to check whether the JSON is being converted to codable? Because maybe there's no other behavioral logic over there.
Well, you can test. It's a very simple test to test that it's converting data to the right JSON. Maybe it's just a function that you call. It's a pure function. You pass data and it returns an array of players, for example, right? It's very easy to test. The cost is very low. Why not? right? Because the view model is not doing this conversion. It will be done somewhere in here, right? The conversion
Exactly.
from data to
You,
the rich array of players.
your view model receives that. Yeah.
Yeah. So this is different concerns. Like this is decoding, decoding logic. Maybe you want some
Yes.
tests in there. If it's a very simple decoding, it's like, you know what, I think the benefits is not gonna be great. And I'm willing, if there's a bug, I'm gonna own it. That's fine. I would write this test. If you ask me, Kai, would you write this test? I would.
Okay.
I would write this test. Now it's up to you to decide if you're gonna write the test.
Right.
Because it's very low cost and it's a pure function and it's easy to test. And I think it would add benefits.
Yeah. Yeah.
Yes.
Definitely.
Had a quadrant the other day, cost and utility for tests. That's very low cost and big benefit. Like big utility. So
Yeah.
absolutely,
Cost benefit.
cost
If
benefit.
low
Yeah.
cost, benefits, write the test.
Yeah. Makes sense.
All right. We also mentioned navigation, but we didn't have time to talk about it.
Yeah.
But one thing I usually say about navigation in MVVM is that navigation has nothing to do with MVC or MVVM. I think it can be separated from that. Like, I don't think that navigation needs to go through the view model, and the view model will tell a router or a navigator to do something. I believe that if you send the view controller sends a message to the view model, and the view model simply send that message to another object without any state change, without any logic, that's just a middleman in the middle there. This view
Hmm.
model is not doing anything. It's just getting a message and passing it forward. That's usually an anti-pattern. So if there's nothing happening in the view model when there is this state change, I would not go through the view model to perform a navigation.
Okay.
I would have probably here a callback in the view controller. I'm the view controller. Yes, in the view controller, I will have something like button tapped closure. Now I would compose this with maybe a method in a flow class that does something.
Hmm.
Yeah.
Hmm.
And then now, when there's an event, a button tapped, it goes straight to the router without going to the view model. So there's one less level of indirection there. Unless there is some interesting logic that will happen in the view model when a button is tapped. But I would try to decouple the view model from navigation,
Yeah.
from animation, from UI transitions in general.
Right.
Unless it's strictly necessary, and usually it's not.
Yeah. Well, one time I did put some navigation logic in my view model, and then as things got more complicated, it got a bit more difficult to handle. So yeah, so that's why this navigation has always need a good way, like flow coordinators. I'm currently looking into that. So yeah.
All right, that was a long session. Thank you for joining us.
Thanks.
Awesome
Thanks
questions.
for having me. Yeah. Thanks, Caio. Thanks,
Absolutely. I
Mike.
mean, thank you so much.
Thank you. Bye,
Bye.
Amin.
Take care.
Bye, guys.
Someone asks here where we create the logic, navigation logic. There you go. We just give you the answer, I believe.
Mhm.
Ideally, not in the view model, unless necessary. Usually, it's not. How to map NSSet relationship property to Swift array in core data. You can just do a for loop or a map. The only problem is that NSSet is not typed. You can have anything in there, so you need to cast. Probably need a compact map instead to deal with the models you cannot convert to the types you care about. I've been working on a project with an MVVM-C approach. May I know what is the difference between MVVM and MVVM-C? There is no difference. There's no such thing as MVVM-C. There is MVVM. It's just a pattern, model view, view model. And now people keep adding letters to the acronyms just to add more specification to it.
Yes.
But C is for coordinator, right? Some kind of flow controller, something like this. Instead of doing navigation in the view models, you want to do it in a different component. You can use coordinators with MVC, with MVVM, because navigation has nothing to do with these patterns. Navigation is something else. Screen transitions can be done in a different component. And just by adding this component, you don't change the acronym name. Otherwise, it's like MVVM, C, and TR. Like everything started adding here. And then you end up with Viper at some point.
Yep, pretty much.
So the point here is don't get too fixated with acronyms and names and templates. Just separate concerns and you end
Exactly,
up
guys.
with good separation and testable components, composable components.
That's it. The fundamentals, you know. Did we have MVVM C like 2 years ago? I don't think so. Or 5 years ago, whatever. You know, it's like maybe we did.
Is provider equals repository?
What provider?
The provider we were writing here in the diagram. In this case, it was a network provider, some kind of leaderboard provider for getting the leaderboard of the players.
Right.
It was a leaderboard provider. It's a different naming convention. Leaderboard. Again, everyone calls things differently. If you read 10 blog posts, you're probably going to get 10 different names for things. Providers, services, repositories. So it depends, So that's why I like reading books. When you read books, you get specific definitions from specific authors. Now, when you talk about services, you can say, hey, in the context of domain-driven design from the book, I'm referring to an application service or an infrastructure service. Things that are more well documented. Otherwise, it's just different names for similar things. So is provide a repository? Usually, it depends, like which definition of repository.
Yeah.
Domain-driven design repository is an abstraction over databases, and they have a very specific
Structure.
that they want to present a database as an in-memory, similar to an array almost.
Yeah.
Where you can get something by ID and so on. There's specifications for it. But there are more loose definitions of a repository. They can say, well, maybe it's not a database. It could be also a backend. So it depends who you ask. That's why don't get too fixated with names.
Yeah.
Unless you're reading a book and they have a strict definition about it. Otherwise, we can get lost in translation here.
Absolutely.
Because when you say repository, you mean something different than what I mean repository. Or when you say provider, you mean something else when I say provider. So we don't get loose in translation. It's good that we first establish the context of something. So reading books will give you good context. Is there any way to get navigation logic in a flow outside SwiftUI view without using UI hosting controller? With only SwiftUI lifecycle? Yes. We showed how to do it.
Yeah. In the Pi series, I believe.
Professional iOS engineering.
Season 3, yes.
Pi. On YouTube. Season 3. The last 3 episodes.
Yeah.
Let's show with UI hosting controller and navigation controllers, UI kit navigation controllers. And then we swap to pure SwiftUI lifecycle. But again, you win no points for doing pure SwiftUI. SwiftUI and UIKit, they interrupt really well. If you're not able to do something with SwiftUI, you can go back to UIKit and vice versa. No problem with that. Unless you say, no, I'm doing this for demo purposes. I want to really stress out the framework SwiftUI and see what I can do and cannot do. Then, yeah, that's fine. We're in a real world project. Maybe you need to be sometimes more pragmatic and use the tool that better fits the job. Navigation SwiftUI is still a bit buggy in some cases when you have complex navigation. So how to maintain multiple errors from network client?
A custom error, maybe? Is that what you mean?
So if you have a view model talking to a service that will return this kind of errors, status code, for example, the view model is already talking to this service. And the view model can decide, oh, if the status code is 404, I'm going to show a specific message. Something you can do. Depending on the error type, you can create a different string. Is that what you mean? Is it best practice to inject router coordinator flow in the view model? In my opinion, no. I don't do it. I don't want my view model or my presenters talking to router coordinators or flows. How do you account for test coverage if you don't test UI? What do you mean don't test UI? Don't test the appearance of things like frames, constraints? I would write snapshot tests. I don't test them with unit tests. But anything that I want to prevent regressions, I would write snapshot tests, for example, for how things look like, and unit tests for how they behave. And remember, the testing is a pyramid of testing. You want to, in the base, the huge amount of unit tests, it's the base of the pyramid, a solid foundation. And then you have other strategies on top of that. We have a podcast about it. Podcast, Essential Developer Testing Strategies podcast. It's a mix.
Yeah.
But the foundation, the primary strategy, they are unit tests. They are fast, they are reliable, they are precise. Wouldn't it become a little inconsistent if sometimes the navigation logic is in the view controller and sometimes in the view model? It should never be in the view model. But the view model can listen to events that also trigger navigation logic and do something like changing its state. But it shouldn't do navigation logic. But maybe it receives a message that the navigation happened and it will just change its state if necessary. But the view model shouldn't decide about navigation. Usually, navigation happens because of a user interaction, and the user interaction goes through the UI, and the UI can trigger directly a flow, a navigation. Otherwise, you need to pass the view model. The view model needs to tell the navigation, the navigator, the router, the flow to do something. And then you have many levels of interaction that you can eliminate without passing through the view model. What do you think about testing view controllers? Yes, I test my view controllers. So my opinion is that you should test view controllers. And you can test them as the entry point, as the public interface. And everything behind the view controller could be private. Then it's more like an integration test. It gives you the benefit that your test will be more decoupled from implementation details. The downside is that if we're testing too many things in integration, when there's a failure, you don't know where the problem is. Could be in the view model, could be in a model, could be in a network, and so on. So you need to find a good balance there. Not test too many things in integration. Otherwise, you need to debug when there's a failure. All right, that's it. You there.
Bye, y'all.